everybody. Welcome to my interview with Professor Barton Smith. He is a professor of aerospace and mechanical engineering at Utah State, and he's made some really big discoveries about the way seams can make a baseball move, ways that previously hadn't been discovered. He calls it the seam shifted wake. Welcome, Barton.
Thank you.
Should I call you Professor Smith? Nah, let me go back too long. Yeah, that's way too formal for this.
Yeah, I'm not doing that.
Yeah, exactly. So one thing I just kind of wanted to touch on is kind of how we met. And you'll remember I kind of was scouring the internet for things on laminar flow, which was the way what Trevor Bauer was saying the forces on his two-seamer were making it move. And I am anal about stuff like that. Like I will go down every rabbit hole there is, and came across a presentation you were giving about why two-seamers move, and reached out to you and said, hey, this is kind of not what they're saying. So I wanted to hear your point of view on it. And then it kind of went from there. Was it weird for me to reach out to you like that?
No, it was really exciting. Yeah, that was a very exciting time in this work. It was funny because we didn't really have anything at the time. We had tools in order to do the work. We were just building the tools that we eventually used to do the work, but we were just getting started. And to have someone, and I was also kind of new to Twitter. So I got to be honest, I wasn't really sure who you were at the time.
Oh, fine.
Yeah, but I had heard of the controversy with Major League Baseball. I was totally missed that whole thing, so I was coming in after that. It became quickly apparent to me that you were a very big deal, and it became really obvious to me that when you retweeted my tweet, it got a lot of hits, which I had never seen before that. I mean, I think I went from 60 followers to, 1,000 within not too long after that. So you always amplified my stuff quite a bit, and it was a huge help to me and a lot of fun.
Well, I mean, I think it's been one of the more exciting developments over the past, year or so, 2 years, because it is kind of the new frontier. I mean, first we had the whole spin rate stuff, and everybody realized that it's not just velo. There are other things that we can now quantify. Why hitters are not hitting certain.
I mean, it's really interesting how that measurement changed the game, because nobody threw high fastballs before that, right?
Exactly. So totally that. And then I started thinking, that is it's almost like a pseudoscience to me. It's a measurement of something. We're not totally explaining some of these things. And it started to make sense to me that actually maybe getting somebody who is involved in this science might take the game a little bit further, might be able to answer some of these questions, as opposed to, hey, high spin rate is good on a four-seamer. It's not, on a changeup, you want to have lower spin. Basically, the nuts and bolts of how we coach. But instead adding some science to it and really taking the game to a whole nother level. So you're the vehicle that is hopefully driving this change. How do you feel about that responsibility?
I had never thought of it as a responsibility until just this second. So I'll have to think about how I feel about it. But let me just go back to that time. I mean, what started me going on the whole thing was the question of what is a two-seam versus a four-seam fastball. And whenever I'd ask somebody what the difference was, I would get answers that were really not. They didn't make sense to me, and so that's what started us down the path. And it took us. I mean, if you'd come to me as recently as a year ago and said, "What have you found out?" I would say very little. We really haven't changed anything or clarified anything, but that's changed a lot in the last little while. So.
Yeah, I mean, I think that you're kind of challenging what people had thought, and I love that, because to me, as we discussed, Driveline has always been at the cutting edge of what we are as coaches. They're doing a fantastic job of measuring stuff. I knew they'd be interested in it the second I reached out to you, because they like being challenged. They're not one of those people. They're not one of those groups of people, and I know Kyle isn't one of those guys who just wants to accept things the way they are. So bringing the actual science into it, I know they were receptive to it as well.
Very much.
Things kind of took off along that.
Right. So they got in touch, and I just said, hey, why don't you come out? We'll all put our time in for free, not involve the university in anything, so that it doesn't get complicated. And they came out, and we had a really interesting. It was a very interesting time. Took some interesting data, and then it started from there. First, we had to get past some of the misconceptions that we all had at that time. This laminar thing that really I was hung up on for a long time. I accepted that, and I tried to explain how that could be laminar, and eventually realized it seems like the ball always goes the wrong way for that, and it took me forever to get to the point where I realized it was the seams and not the smooth parts of the ball that were making the difference.
Very interesting. So let's start. I want to give everybody a little bit of background on you, and then we'll get into how the seams actually make the ball move and some of the science behind it. So I know that you're a Georgia Tech guy, and you went to all the baseball games there too while you're there.
Yes, yeah. As far as anybody knows, I went to all of them. I don't know what the stadium's called or what part of campus it's on, but I went to every one.
It's Russ Chandler Stadium. Come on. What was your doctorate in?
It was fluid dynamics and what we call flow control, which somewhat ironically is loosely related to this work. Flow control is the idea of doing small things to flow over something to make a big thing happen. And the best example that everybody knows about is the stuff they put on wings. Originally, there were just little pieces of metal that stuck up out of the wings. They call Vortex Generators that keep the airplane flying when it's going slow. And the bigger one that you see these days that's really prominent are the tips on the ends of the wings. That's a passive flow control device. And I've been arguing now, in fact, if you go back and look at one of our first presentations, it's called our baseball seams flow control. And I contend that they are.
That's awesome. I didn't know that. So what do your compatriots at Georgia Tech think about your baseball stuff? It's way cooler than designing planes and stuff, right?
I agree that it's cooler. I'm trying to think if I know anybody from Georgia Tech that was. Yes, I have a good friend. I'll shout him out right now. His name is Daryl James. He's now a vice provost at Texas Tech. His son plays baseball. He's in the minor leagues, I think in the Kansas City system, and he thinks it's pretty cool. He was on the Zoom call the other night. Other than that, my advisor is from Israel. He's not too into baseball.
Did you ever think that you would be doing baseball stuff while you were studying it?
No, I didn't. I realized about 3 years ago that we could do it, and I had that interest, and so I started putting some meager resources into it. That almost died on the vine. A student worked on it for a little while and dropped it, left, graduated and left. I had another student come along that needed something to do. And I'm like, why don't you pick that up? And if that hadn't happened, we wouldn't be having this conversation right now. If that student had been funded and had a job to do when he got there, we wouldn't be doing baseball right now.
What would you be doing otherwise, though? Like,
I don't even want to talk about it. It's so boring. We do experiments to take data to compare computer models to, and it's guaranteed to make anybody's eyes glaze over when I start talking about it. It is the worst research work to try to excite the public about that I've ever thought of. I mean, I hated to try to, we would always be encouraged to try to sell our work to the public and to explain to them why what we do is important. And it was so challenging to do that. Now I get to talk about baseball, and it's like both extremes. I work with a lot of guys that work on space or rockets and things like that. And whenever I had to speak after them, I would just throw up my hands and say, "This is terrible." Nobody wants to hear what I have to say. But now I get to talk about baseball, so it's fantastic.
That's awesome, because baseball is way cooler than rockets, and I know they think that too.
Yeah, baseball is cooler than. I'm going to go off on a rant here, and I think baseball, and the baseball in particular, is an amazing object. It's amazingly complex, and it's really rewarding to study because it is a puzzle that's very difficult, but reveals itself slowly. And
that's amazing. So this is what's amazing to me is the game's been around for forever, and we are just now scratching the surface of this simple thing right here that has seams on it. We assume certain things about it, about what makes it move, and we're discovering new things now. So, I
Yeah.
mean, how cool is that? And how cool is it to be at the forefront of it?
Yeah, and now you make me wish I had poured a beer, because I'd like to salute Mr. Spalding, who decided to stitch it together this way, or decided to manufacture them this way. That's my understanding of the history. Is prior to him patenting a way to manufacture them, they were built all kinds of different ways, but they settled, the fact that he was making so many of them like this made everybody say, well, this is a baseball. And if you'd done it differently, like a cricket ball, this would be a much shorter conversation.
So that's why baseball is the best.
It is objectively the best. I like to tell people. Did you hear the seminar title I came up with the other day?
No, I didn't.
I was going to present this in Europe. The title was going to be, and my friend Doug Neal talked me out of it, why the baseball is more interesting than your sports ball.
Well, trash talking. I love it.
Yeah, but I really feel like it's true. It's not a hyperbole at all to say that, because people will talk a lot about some of the interesting things that happen with soccer balls when they're made certain ways, but that's just going from laminar to turbulent, and baseballs have the seams do so much.
It's really interesting too, because unlike soccer, at least in a pitcher's mind, I mean, a pitcher is in total control of it. Soccer, you have someone coming at you. I mean, you're doing something with it, so it's not totally in control. A pitcher can shape a pitch a bunch of different ways. So knowing the science behind it, for some, could lead to a whole bunch of new pitches.
Yep.
Where in soccer, it's tougher.
Yep, and just a shout out to you. I mean, the overlays and all this kind of stuff has really, I think, opened people's minds or made them realize that there is so much richness to pitching. The stuff that you had in the playoffs about the Tampa Bay bullpen and all the arm angles.
It's great. Like, we're just now uncovering all this stuff and ways to defeat hitters, which is kind of awesome. I mean, now we're enlisting high-powered scientists on hitters. They're hosed. Like, what are they going to do?
Yeah. Yep. They'll get better.
Right. They're going to have to. So let's talk about reasons why a pitch might move. Scientifically, seam-wise, explain to me the difference between Magnus, laminar, and then how the seam-shifted wake comes into play. Okay.
I have a series of what I call speared baseballs here on a rod, and this one is a 4-seam. So if I am a pitcher that throws directly over the top, which I guess would be kind of like this, that ball's coming at you, it's going to spin like that. And it moves mostly because of what's called Magnus Effect. And the easy way to think about Magnus Effect is it's going to make the ball move in the direction that the front of the ball is moving as it spins. So the front of this ball is coming at you, so it's spinning like that. It's going to push it that way. And for a fastball, it means it obviously doesn't rise. No offense to Hank Aaron, but it doesn't rise. But it fights gravity. It would drop a lot more if it wasn't spinning. If I'm a extreme sidearm pitcher and try to get over here, throwing it from there, now it's going to spin like this. Front of the ball is moving that way, and that's what you see in a lot of these more 3/4 or sidearm guys, is a lot of horizontal movement, which is easier to see because it's not fighting gravity. And so that's the bulk of it. Then the curveball is I lost it here, but the curveball is spinning the other way. It's spinning down, so it pushes down, and that's the bulk of what's going on. Or until recently, we thought that was everything that was going on: gravity, drag, and Magnus Effect. And what we've been able to demonstrate is that there's another force that we call seam shifted wake, and it's probably almost as big as Magnus.
Interesting. So almost as much effect on the ball as Magnus?
Yeah. I think at an instant in time, it's as big as Magnus, but it doesn't happen all the time. As the ball spins, it comes and goes.
So explain to me a little bit more about seam shifted wake. What makes that happen? What type of pitches does it happen with, and what's kind of unique about it?
Well, what happens is I'm going to try to make the ball now moving that way. If there is a seam that is kind of near where the rod is in the center of the ball, then it has an effect on the flow. It tilts the wake. If the seam, like this seam up here, which is near in the middle of the ball, would make the wake tilt downward and would push the ball upward, but the thing's spinning around, so it's gonna go up and down and up and down. And the baseball's way too heavy to change its direction every time the ball spins around. So the whole game on seam shifted wake is making a seam sit in one place most of the time. So if I take this ball and spin it now, I'm hoping, and you're gonna have to confirm for me, that you can see that this looks like it's sitting still. If I take the 4-seam ball and do that, you don't see anything like that. You see the logos, don't get confused by those. If I take a ball and I just do straight 2-seam, so this is a straight 2-seam, I kind of see that, but not really. So to answer your question, what you need in order to make this happen is the ball to look asymmetric somehow. If it and the 4-seam is as symmetric as you can get. There's stuff just flying all over the place. So 2-seamers tend to be seam shifted. If I just throw the 2-seamer straight like that with my fingers right down the middle, it'll do a bit of seam shifted wake. It'll move a little bit extra to the arm side. If I am more clever and I have that, you see that ball is a little bit off center, I can make it go more so. And so that's what I think the difference between the ones that work really well and the ones that work less well.
So how much of a difference is it? So you're taking a normal 2-seamer that everybody a lot of pitchers throw, versus seam shifted one. How much additional movement do you expect on those? And I know it varies.
It varies a lot, and we don't have a precise measurement on that. The reason is that we need to know how much gyro the ball has in order to separate Magnus Effect from the seam shifted wake effects. The ones that we've done in my lab, we've generated about 8 or 9 inches of break from seam shifted wake, and I think that there are examples where it's quite a bit more than that. I think it's on par with Magnus, and Magnus, you know, the numbers are 16, sometimes 20 inches, I think, in some extreme cases.
And that's amazing, because this is an effect that nobody had thought of, to my knowledge, before you named it. Is that
right?
correct?
And the reason for that, I think it's kind of interesting. So we had, we kind of started off talking about the measurement systems that the MLB employs. There's a nice rundown of this in the article we just had in Baseball Prospectus about the early pitch effect system, and then TrackMan. There was several stages of this, and each time they went to a new system, we would get more of the parameters of the pitch measured. And with TrackMan, we measured the break of the ball, both horizontal and vertical break, and we measured how fast it's spinning. And you can take those two numbers and you can say, I think only Magnus Effect is happening. And there's a pretty simple formula you can run it through, and it'll say, this is the axis of the ball. The ball is spinning on that axis. And what we've recently found out is, no, it's not spinning on that axis, it's spinning on this axis. And the difference between those two is all seam shifted wake.
So you call that inferred versus observed, right?
Right. Yeah. There's some folks have suggested, and I kind of like this, that instead of saying observed, we should just say true. It is
right.
the axis.
Yeah. And that's all because of the optical measurements now, the Hawkeye type system? Hawkeye
actually takes pictures of the baseball as it flies. And so they know exactly what the axis actually is.
So something like a Rapsodo or a Yakkertech device, those take pictures of the ball too, but their formulas were designed around Magnus. Is that right?
I'm going to explain my understanding of those technologies, and okay. With apologies to those guys, because I might have some of it wrong. Rapsodo, which is the one I'm most familiar with, takes pictures of the baseball, and the description of the axis that it gives you is based on those pictures. And that is, by my understanding, that's the same as what you get with Hawkeye. Rapsodo also tells you how much it thinks the pitch will break on the front of the app, and that is from a Magnus model. So if you have a seam shifted wake, the movement numbers from Rapsodo will not be correct.
Which is interesting, because I also think hitters have their own. So a hitter is going to have his own calculator, basically. A hitter is a brain is a computer. They're used to seeing certain pitches move a certain way. They're used to seeing true 4-seamers, maybe a cutter, whatever. But if they see a seam shifted wake pitch, they, in my mind, may calculate that pitch to move differently than it actually ends up moving, which could make it more effective. Is that a good way of looking at it?
I think that's exactly right. And I think the best example of this, or the one that we haven't, I'm very interested in proving that point using Kyle Hendricks as an example. So I was reading Jeff Long's article recently about tunneling that Hendricks does. And he talked about how important it is that Hendricks releases the ball very close to his body, and which would seem to say that the axis is going to be very straight up and down, but he has a very seam shifted two-seamer. And so it behaves like it's more like that. So it moves much more to the right or to the arm side than it should. And that's got to be confusing to the batter. So they see this high arm slot, and then they see the ball break heavily to the arm side.
Yeah, there's a pitch, and I might send it to you. I forgot even that it existed until we were just talking. But there was one that was a two-seamer of Kyle Hendricks that kind of blew my mind. The way he released it is pretty unique to me, at least. And it may have been that specific pitch, but I have it in slow motion, and it kind of looks like he was cutting the ball, but it was actually a two-seamer. And everybody that saw it was like, "What the hell's going on here?" So I think there's absolutely something to it with Hendricks. And it's one of those things that, Kyle Hendricks is a really smart dude. There are a lot of smart, not smart, whatever. Pitchers tend to be smarter than your average baseball player in general. I mean, obviously, we all know that. I'm not biased at all. But none of these guys have done the scientific studies on it. So these are pitches that they would throw through trial and error, say, "Hey, that one moved a lot. Maybe I'll try to do that again." But now you have a reason behind it. Yeah. So I'm curious. I know you've worked with some major league pitchers. What have they thought when they've seen this effect, and you've pointed out to them?
I haven't had a chance to talk to very many major league pitchers since about pitches that they're already throwing since we figured this stuff out. I got to talk to Jared Hughes a lot over the off season. He was the one that told me that his four-seamer gets a lot of seam shifted ride to it, and he knew that it rides. He didn't know why. He knows it rides when I throw it like this, and then that's feedback he gets from his catcher. So I think there's been a lot of that. Now he understands it, and I think he does it on purpose. I haven't had that full feedback loop with many guys. I talked to Trevor Bauer a little bit. He's a really interesting case because you might have noticed he didn't throw any sinkers this year. I counted 12 that he threw the whole season. And I think it's because his four seam has become so good and his other pitches that he just doesn't really rely on that pitch anymore. But I think he understands it, but now he's decided not to use it, which is really ironic. Let me back. I lost my train of thought there. You were asking me about.
Oh, just other pitch, because it seems like if I'm a pitcher, I kind of want to know this stuff. I want to know how to use it. What if I lucked into it? How to recreate it? So it's not just called trial and error.
I haven't had much luck reaching out to pitchers and having them respond that they want to know more about this. I kind of make the analogy to pilots don't really want to know aerodynamics. They want to know enough to make the plane fly, but they don't really care if they understand exactly how it works. They want to have a bit of an intuitive feel for it. And I think pitchers are kind of this, a lot of them are kind of the same way. I could be wrong. And if any pitchers are watching this, I would love to talk to you about your seam shifted weight pitches. I've reached out to Brad Keller recently. I haven't heard back. He's one of the most extreme seam shifted weight pitchers in the league right now. His two seam and four seam move in opposite directions more than anybody. And he's a young guy, just pretty new in the league. So I'd love to talk to him.
That's interesting. You also had Tanner Houck and Sterling Sharp. I know Sterling had some on there as well.
Yeah, Tanner's right up there. It's a strange list when you look at the people that this is happening a lot to. Most of them don't throw super hard. That seems to be a common denominator. A lot of them are very good. I saw Dallas Keuchel, Sonny Gray, trying to think of some others.
Adam Ottavino, I think, was on that list, who occasionally will throw pitches that look like they're in time warps or something. They have some new.
Let me go back to Hendricks, though, and I want to contrast him with Dustin May, two people that are a lot of people are familiar with. So the interesting thing about Hendricks is he throws his four seam and his two seam exactly the same way. He releases them the same way. They have exactly the same axis, but one of them, they move in opposite directions. as a result of this effect. And they move, what's interesting to me is they move by the same amount. So he's trading the Magnus movement on his force seam for seam shifted wake movement on his sinker. Contrast that with Dustin May, who you spent a lot of time looking at, and the so-called demon sinker. In his case, he's able to actually add movement with the seam shifted wake. So he doesn't give up all the Magnus. He gets a lot of that too. And that's why, in my opinion, that thing goes like it does.
Gotcha. So I guess the one thing that I keep coming back to is, yes, pitchers do it through trial and error, and maybe they don't want to understand why that happens. But to some extent, understanding why it happens makes you be able to recreate it more often. So if you know that this axis is right, like it's no longer luck, it's you can recreate it.
Right. I think that was important for Hughes, because this thing comes and goes. If you don't grip the ball exactly the same way, it can be a very subtle difference, and all of a sudden the effect is gone. And to realize, I think for him to realize, hey, it's the ball has to be oriented in my hand the same way in order to make this happen consistently, and I have to have the right amount of gyro to go with that. If you don't know what those two knobs are, and all of a sudden one day it's not working for you, you're going to have no idea why.
So let's explain the combination of gyro and just what type of axis you mentioned. Obviously, it's got to be consistent.
Yeah.
Number one, does a pitch always stay consistent? So there's forces on the ball. There's whatever ballpark forces there are. Obviously, things move. They shift axes and stuff. Is there a way to make sure the axis is consistent? Are there different? I mean, what else goes into this?
That's a totally open question, and I want to get back to talking about the gyro in a second. But there's a lot of discussion amongst types like myself about whether or not the axis is consistent, if it changes as it flies. And I think the answer is it doesn't. Then the next question is, does it matter? Does it change enough that to be significant? I've seen a couple pitches just this season, and it's obvious that the axis is changing as it flies. One of them was a slider in the playoffs this year, that you could see the dot on the back and you could see the dot shifting as it flew. And then the other one was the Kratz knuckleball, where it's obviously starts to accelerate. It starts to spin more as it flies. So obviously that says that that's possible. Does it matter? I don't know. And I have so many other things I'm trying to figure out that's one that I'm just saying, I hope it doesn't matter. And I'll turn that rock over later on.
Right. So it may matter for, like, it could be how long it stays on that axis. It could be, I mean, there could be a variety of different things. It's still, we're just scratching the surface of where this concept even is.
Yeah, I think so. And you kind of alluded to it. One of the things that I think is really exciting about seam shifted wake is the possibility that it changes its action as it goes. And the reason that can happen, again, I'm going to refer to this ball again. If I had the seam here, as the ball's flying that way, and I had the seam here right where I want it to be to make the wake go up and the ball go down, now the direction that the ball's traveling changes. So say it's late, initially it's flying into the air like this, but as it starts to fall, now it's traveling in a different direction, and this seam relative to that direction is in a different spot. And I think there is a possibility that force changes as it goes, and that's going to be especially confusing to a hitter.
So you may get two different forces on it, or directions on it.
Right. Well, just like I like to think of seam shifted wake pitches as knuckleballs. They're knuckleballs that are spinning. And so knuckleballs, we've always known that can go two different directions, right? It can change what's happening as it flies. That's what makes it so special. I think that can happen on these spinning pitches too.
So that part's fascinating, because I think we've always assumed that there is a consistent spin, a consistent movement, that pitches don't necessarily change directions in mid-flight. And now we're saying, well, maybe they kind of do.
The way that the data is recorded kind of fixes it. The way that the pitch data is recorded does not allow for the possibility that the pitch changes.
So this part's amazing, because you'll hear feedback from either a catcher or a hitter that says that pitch looked like it broke two different ways. Or sometimes, actually, there are a few times where I'll have videos and it'll look like that pitch is breaking two different ways. But I've always said, well, that's probably an optical illusion. Now
I
we're
think
saying that maybe it's not.
I think a lot of times it is, but I think that doesn't mean it's not possible either. I think it can happen. I think we found a way that it can happen.
That's
So we're trying to. I spent yesterday morning looking at pitch tracks and trying to determine if it is happening. It looks to me like the data is not sufficient to make that determination. Hitters will have to tell us that.
yeah,
they all already think it happens. So.
right, exactly. Like I've gotten that on even things like overlays where it looks like it's happening, and then you hear from a hitter. Like, I mean, there's an interview with Chris Bryant looking at one of my overlays, going, "Yeah, that's what it feels like in the box." So I think the key is hitters aren't necessarily going crazy when they see this effect, and we're just because we couldn't measure it before doesn't mean it doesn't exist.
Right. Yep. For a long time, we were fighting a battle where people would not believe what we were saying because the measurements don't show it, when the measurements are incapable of showing it because they are output in a way that if it were happening, they would smooth it out. And that was very frustrating because I understood this issue, but it's hard to explain. So the pitch is basically, they say where they let it go, how hard it was thrown, and which direction it's accelerating in. And there is no possibility of that acceleration changing along the pitch. It's given one value. So yeah, it can't, when you look at the output data, it's not possible to see it if it was happening.
What's fascinating about that is then you see the break on a pitch in one value, that this pitch broke 18 inches, but we don't know. There could be a such thing as late break. There could be intermediate break too.
If there was, we wouldn't know it. There's no way, given what the measurements that we have right now, that we can know it. I'm hoping that'll change in the next year. I think that there's going to be enough focus on it, and it's totally technically possible to do. It's just that there's not been the motivation to make it happen.
So these are the same scientists that said a curveball didn't curve at first and stuff like that. And
it might be their descendants.
yeah, exactly. Because I remember that I forgot who the pitcher was. Said, yeah, hide behind that tree over there, and I'm going to whomp you to death with my curveball. I mean, hitters know this stuff happens, but they've been told that it didn't through science, which is doing its best. I mean, you can only do what you can do.
Yeah, I have a blog that you know about, at baseballaerodynamics.com. It's got 61 posts on it. And if you go back and read through the 61, you'll see me contradict myself at least 20 times on many of these same issues. So
see, I love that.
I think that in order to make that progress, you have to be willing to say, hey, I had that totally wrong. I'm 180 degrees off. That happened to me a lot.
I think that's probably the most important part to me that separates what I would consider a smart person from someone who seems smart. Like, people who seem smart, if you insist that you're right and you have the answer to everything, that makes you feel good, and that makes everybody think that you're smart, as opposed to saying, I don't know. Like, I think it's it, not real certain. That would be a good
yeah. Yeah, there was a point in time where I had something on my blog that I decided was wrong, and I was walking it back. And my department head, who was a good friend, said to me, you can't be putting stuff like that out there. You don't want to be wrong that much. And I'm really, I think in the academic community, he's probably right. But for us to learn what we've learned, to get the input from guys like you and other people in the community that have been willing to engage with us, I think required that kind of humility and that kind of putting false steps out there to see how they work.
Well, honestly, someone like Trevor and Kyle Bodie with the Laminar Express, they put that out there, and they were also open to be, and this is one thing that, I mean, I told my kid, like, yeah, it's laminar flow. If you do this, it's going to take off and break that way, because it seemed right. I mean, they do the experiments, they put themselves out there, but they're also willing, as I said before, to be contradicted. And I think that's the key to, I mean, it's almost the key to anything, to be successful, is a growth mentality.
Yeah, and I totally agree that they were very gracious about me disagreeing with them about some of that stuff. And it's also a fact that I would not be doing the work I'm doing right now if they had not put that incorrect theory out there. I picked up on it and said, hey, I want to prove that these guys are right. And at the end of the day, I feel kind of like I proved that they had the right idea for the wrong reason, or something like that. But without them saying this pitch is special and here's an idea about why it's special, I would never have picked up this path.
I totally agree. Actually, I wouldn't have been going down that rat hole to try to find more information about it. I was looking for the science behind it because I don't like accepting anybody's word for something. I like to drill a little bit. I don't have like my own chambers that I do these tests and stuff in, unlike some people.
But you can put out your test in our chamber anytime you want. So.
I do have a basement with a Rapsodo and a bullpen, as we were talking before this call. So I do some testing, but not like you.
Yeah, if you get a compressor, we can put the cannon down there.
Awesome. That'd be fantastic. But so I guess the point is we need people to keep challenging the status quo as opposed to just accepting the science behind it. Yeah. And we can create new pitches.
Yeah. Don't accept the status quo, because when it comes to baseball, people wave their hands a lot, and I think they mean well, but I don't think anybody really gets it. And like you said, people will try to act like they do. And here's a really good example. We decided to mess around with scuffing a baseball a while ago and to test it in the lab. And so we grabbed the ball and I put sandpaper. I just put it on there and we stuck it in our cannon like that and fired it. And I set my net further to the right because I was pretty sure that that's where the ball was going to go, because I had a textbook that said it would. And it went the other way 2 feet and it hit our garage door and made it at 90 miles an hour, made quite a racket. And so then I Googled that, which way does a scuff ball move? And I find John Smoltz talking about it. He's like, yeah, it moves towards the scuff. He knew.
Not that he would ever scuff a ball.
Yes.
But yeah, no, exactly right. So we're talking now about being able to confirm what humans see. Like humans who play the sport know this stuff.
Right. And humans are a great source of hypothesis, or, I'm going to test that idea. And I think we have to listen to them to say, this guy says it happens like that. So, okay, I'm going to go look at that question. But at the end of the day, I've really felt like I needed to investigate every aspect of this myself. And because we have a method of testing it that nobody's had before. So yeah, look at all these questions in detail and make sure that you understand what's going on and try not to wave the hands.
So you were just talking about the scuff, and I know that you came up with a seam orientation. I don't know if it's been still proven out there that mimicked the scuff. Is that still holding up?
Yeah, it didn't work that well, but it was kind of, this is we call this looper. I don't know if we'll get into that, but
yeah, sure. Let's talk.
If you took that rod and instead of coming out where it is, if it was coming out that seam, and we spun around that seam, we'd call that a scuff ball. And the idea was just to have a seam that's a bump right on top of the ball as it flies. And that worked pretty well, but the problem is that only about that much of the seam is doing anything in that case. And so you don't get a very big effect from it. Whereas when we scuffed the ball, we put a scuff that big on it, and it had a huge effect. I talked to an unnamed pitcher who might be listening to this, who told me about an occasion this year where he received a ball that was scuffed, and the scuff was right here. And his theory was it completed this circle. And I have the video of that pitch, and it was impressive.
Oh, really? Yeah. Oh, we're going to have to add that into this.
I don't know. Yeah, I'll have to ask him if that's.
Well, how about we just cut out the picture and I'll just blur out the.
If you can obscure it, yeah.
I mean, if he received a ball that was scuffed, that's different than scuffing it. So that's technically okay. I mean, that would be my story too.
Yeah. He tells me that this happens way more frequently than you would think.
Yeah, and sometimes it's because the catcher it never would happen.
Well, I don't know if you've ever seen the famous Freddy Garcia splitter that everybody realizes. I'm pretty convinced that that's a scuffed baseball. People have spent so much time trying to explain what that ball did, but it's all explainable by there being a scuff on the side of the ball too.
That's interesting, because that makes a lot of sense now. Because that was one of the pitches that got me into kind of the aerodynamics of baseballs. Because everybody looked at it and goes, "What the hell's going on there?"
Right. Would you think Freddy Garcia would never scuff a baseball?
I think most pitchers, given the, I mean, why not?
And I don't mean to disparage Freddy Garcia. My son just got a 44 glove, and he inscribed underneath the hand, it says, "Just make pitch," in honor of Freddy Garcia.
I know your son's playing. Are you teaching him any of this stuff?
Not yet, but my son, and we haven't gotten into this yet, but this stuff is all pretty heavily reliant on having a bit of gyro to your pitch. And I've been working for the last year trying to eliminate all the gyro in Sam's pitch. And it suddenly hit me that could be a advantage when it comes to this stuff. It absolutely is an advantage. So being 90% efficient instead of 100 is much better. And so that as soon as you tell me this guy's 90% efficient, I know his four-seamer and two-seamer will break in opposite directions.
That's a really interesting point. And that's something that maybe even college coaches with Rapsodos and no spin efficiency might look at.
Right.
Everybody's so focused. So this is a point I want to explore a little bit, because everybody is focused, and they have been focused on spin efficiency. So to everybody, like grading, 100% is better than 90%. Right. What you're saying is there are situations where 90% may be better in terms of getting hitters out and creating movement to the pitch.
Absolutely. We already know that, because a slider is a very effective pitch, and it's very inefficient. It's one of the problems that a lot of people have with the term efficiency, is it implies if you don't have it, it's bad. Can I give an object lesson on what efficiency and gyro are?
I would love to.
Okay, so let's talk about that a little bit. If this, I usually like to do it like this. If this is a fastball coming at you, this would be efficient, and it's efficient because this rod is straight across. If I tilt one end toward you like that, that is less efficient, or another way to say it, that ball has gyro now. And that comes from pitchers not keeping their hand directly behind the ball. And as you were just saying, there's a lot of focus right now on trying to make zero gyro, high efficiency pitches, because for fastballs high in the zone, they get a lot of swings and misses. And for curveballs, that basically means it's going to break more. But what I'm saying is that if you want these seam effects, you need to have a little bit of gyro. So if you've seen my pinned tweet with Christopher Watkins saying, "Have you considered more gyro?" That's my. I'm going to keep beating that joke until somebody laughs at it.
I'll laugh.
Okay, thank you very much. So now, if I go back to, I want this seam to be on top of the ball, and it's not. But if the ball is heading that way, and I tilt it back like that, which is to say it has gyro, now it is on top of the ball. That's why you need gyro in order to make these things happen.
So you're seeing a kind of I don't know how to, like a non-symmetrical seam. If they're symmetrical, you won't get that effect.
If they're symmetrical, if the force is symmetric and nothing happens.
So you need an asymmetrical force.
You need to unbalance it somehow.
Seam,
If you go to the four seam, this is, I have a video on YouTube about this, just a short video where I explain this, but I'm struggling to find okay, here's my four seam ball. If that's got no gyro, it's symmetric. But now if I put some gyro into it, it's not symmetric. These seams are going to cause a seam shifted wake. These seams are in the wake of the ball, and the wake of the ball doesn't matter at all. So now that's why the four seam goes the opposite way of the two seam.
Gotcha. So let's go a little bit more into, because we keep tossing about the seam shifted wake term. So what it's actually doing is creating a wake due to it being in front of the ball and kind of forcing the air. Why don't you describe it, because I'm going to butcher it.
Okay, so if
you're the guy who invented it, come on.
Actually, the term comes from Andrew Smith. Got to give him credit. He was my student, came up with that. But the idea is, if you have a ball that's traveling over here, it has a wake behind it. And you think about, if you've ever driven behind a truck, you got to have an intuitive feel for, or in cottonseed season when they're all flying around, you can see that wake behind the truck, right? And it's straight. But what seam shifted wakes do is they make the wake bend in one direction. And if I had that seam there, I'll tell you, it'll move down, which means the ball's moving the other way. And so basically, it just changes the symmetry of the wake, pushes it in one direction. Magnus Effect does the same thing, by the way. If I'm spinning the ball like that, what that does is make the wake shift down. So it's exactly the same kind of effect. It's just that the seam shifted wake's not coming from spin, and the Magnus Effect does come from spin.
Gotcha. So what's that pitch you have behind you? I see a wake behind you.
Oh, that's the Fergie Jenkins ball. So that's a I'd be happy. In fact, did I send you a copy of that?
I think I do have a copy of that. Yes.
It's that. Take it out of the sleeve, man.
I haven't. I just wanted you to talk about it. Come on.
Okay, I've totally stepped on your line.
Yeah.
All right. So, yeah. So that's a ball that Fergie Jenkins autographed for my son at a spring training game a couple of years ago. And the cool thing about our setup, our chamber, is that you can fire baseballs without damaging them. There's no wheels or anything like that. And so I felt comfortable taking this nice, pretty baseball and putting it through.
Yeah, so you offered me to send a ball, and I was chicken because I have a Greg Maddux one sitting here, and I would love it through that. But then I was like,
Sparky Anderson ball. I have a ball it's on our website. It's signed by Alan Trammell, Jack Morris, and Sparky Anderson that we put through that machine.
Nice. Yeah. All right. So you're putting your money where your mouth is. I like that.
Yeah.
Explain more about this setup. So you have a setup. How hard would it be to recreate that? Say you're me and you want to spend money on it. How much money would I have to spend on this?
About $100,000.
Oh, so that's it.
Yeah, maybe a little more than that.
Yeah, and then I'd have to also know what I was doing, so that would be tough.
Yeah, or you could invite me over and feed me some beers, and I'd show you how.
We can do that. So what does it entail? So you have something that shoots the ball out. You have a cannon.
A cannon that
you have measurement stuff.
Yep, cannon is from Washington State. They developed it. The cannon is really cool. And I don't know if you want to try to put a picture into this later on, but the cannon holds the ball kind of like a human hand, and one side of the hand is sticky and the other side is slick. And so when the cannon stops moving, the ball sticks to the sticky side, slips on the slick side, and it spins. And the really cool thing is all I have to do to change the axis of the ball is to turn that tip. So I can go from fastball to curveball with the touch of my finger. And so it's really slick. So that fires the ball, and it fires the ball, in a really repeatable way, which is super important to what we're doing. And then the ball travels into this box. When it gets to a certain location, we flash a couple lasers that are formed in the sheets. And so they're basically flash bulbs, but they are flash bulbs that only hit the ball in the center of the ball. They only light it up there. And we put little fog particles. We actually have a disco smoke machine in there, and that those particles get lit up, and then we measure how far they move. It
doesn't surprise me that you have because you came up with a disco ball for Strasburg's changeup.
No, that was Michael Augustine came up with that. But
okay, good.
I've been a big fan of it, which I think by the way, if you're not familiar, disco ball changeup is when your changeup spins like that, like a disco ball.
And that is a seam shifted wake pitch as well.
Half of them, from what I've looked at, half of changeups are seam shifted in majors right now. 90% of two seamers, half of changeups, about 20% of four seamers. And
pitchers have no idea. They just
I think the ones that are the ones that you are usually showing on your channel, the ones that look two seam. And I think some people throw up more four seam, and those don't move as much.
So this could be also a reason, and I'm going to extend it a little further, why you may have some pitchers that go in slumps. They may it may be, what would a 10% shift in axis do to a seam shifted wake pitch?
It can totally kill it. And what's more, if your efficiency changes, it can either make it better or worse. So we talked about gyro before, and these special orientations that I keep showing you, those are designed for a certain amount of gyro. And so if you have more or less gyro, now that seam is moving from where you want it to be to somewhere else. So one of the really interesting stories I've heard this from two guys. I've heard it from Trevor Bauer, and I've heard it from Eric O'Flaherty, that these things happen when you're not right. In Eric's case, he talked about having a bench press contest with Brian McCann before the game, thinking he was not available, ended up getting put into the game, and they put him in with bases loaded, nobody out, and he struck out the side. And he said he was getting this crazy movement. And I think that when you hear stories like that, it's because the amount of gyro he was putting on the ball is altered by the fact that he's stiff. And Bauer's story was that he had the flu and he was pitching in Toronto, and not himself. And my guess is that alters their gyro. And so a small change in your gyro, small change in the orientation of the ball can make this come or go. And I think this has happened to a lot of pitchers and they don't know why.
So you may have someone, and I'm going to throw him out. I know that we've talked about him, or I've talked about him, is Blake Trinan, where you may have a season where all your pitches were of a certain spin axis, then spring training comes and you lose it. You hear pitchers that lose it, their pitches aren't moving the same way. This potentially could explain some of that.
I think it likely does, in my opinion. It definitely happened to Jared Hughes.
Very, very interesting. So that, again, you may also have some coaches that are meaning well. So we have all this ability to now determine spin efficiency and determine spin rate and all these other things. So as a coach, I'm going to sit there and say, hey, this is what a slider should look like. This is the spin efficiency of a fastball. You need to move your hand over here to have it be a better pitch. But in trying to help somebody through my pseudoscience, I'm actually potentially hurting somebody who's been able to get people out.
Yeah, we're applying leeches, really. I think it kind of comes down to that. If you don't understand what's going on, any attempt to fix it is likely to make it worse. So yeah, I think that's happened. Furthermore, another topic, it's a little off of what you're talking about, but this whole business about inferred axis has caused confusion from pitchers I've talked to, because when they're in the game, what they get back is inferred axis. And then they go into the bullpen and they use a Rapsodo and it tells you your observed axis. And they're not the same. And pitching coaches looking at that say, hey, why aren't you throwing it like you normally do?
So, I mean, it's kind of blowing my mind, because it actually could be exactly what we're discussing right here. The access to technology is awesome. Like, I love the fact of having all this stuff and now being able to measure things. But if the measurement itself is incomplete or making assumptions, you may use that measurement to actually change a pitcher for the worse, or things won't even match up with that pitcher. You're changing him a way that is in the bullpen and not in the game.
Yep. The technologies are fantastic. And I love them all. I'm a huge Rapsodo fan. Use it with my son a lot. And the price. The side story. When we first started talking about doing these measurements, was right around the time that Rapsodo hit the market. And when I heard of it, I thought, there's no point. They've got everything figured out. I'm not going to bother. For $4,000, it would cost me $100,000. They're going to do it for $4,000. So, and it's amazing technology. The trouble is when you don't understand the limits, and TrackMan measured the spin rate, but not the axis. And then you had things like Rapsodo that measure the axis, but not the movement. And so when you put it all together, you can get the clear picture. And now Hawkeye tells us all of that. But the issue was when people, I heard a quote the other day that I really love. It's from Mark Twain, like all the good ones are. And he said, it's not what you don't know that's trouble. It's the things that you're sure of that just ain't so. And and I think that these technologies generated a lot of problems like that, where people be sure that they know what it's telling them, but it's not really what what it means. And so they're certain of themselves and they're wrong.
Yeah, I mean, I'm guilty of that as anybody. Like, I have one of the original Rapsodo models. I love it. And you think, huh?
You still have a one?
I still have it. Yeah. Well, no, but I had it upgraded to the one on. Yeah. No, because the other one I used to hit all the time. Like you'd on the pole and you'd hit it and it'd mess everything up. You have to recalibrate.
Yeah.
Now, if you hit it, you really suck.
I won't tell the story of the time we hit ours because it doesn't belong to me.
Mine does belong to me, and I love those guys. So I love what they do. I've played with the Yacker Tech too, and that technology is awesome as well. But it shows that technology in the wrong hands, while it makes you feel good, it isn't the full answer, and we're scratching the surface of a lot of this.
Yeah. I will say that I think Yacker and Rapsodo both have an opportunity right now to really make this kind of stuff that we're talking about super accessible, because it doesn't require any change to their hardware at all to provide the kind of information you need to know if you're getting these seam shifted pitches.
Have you talked to them yet?
A little bit.
Okay.
I'd like to have a more serious conversation, but Rapsoda definitely knows this. Yacker, I haven't talked to so much.
Yeah, I mean, we can make introductions on all that stuff. And they'll be watching this. They'll know.
I talked to Seth a long time ago, probably almost a year ago, at some length, and he sounded very interested at the time. That was right when the pandemic hit. He told me, they're really taking a hit, and
Yeah,
I'm not sure what happened.
yeah, no, that.
But it's just coding now. I mean, they have photographs of the baseball. They have images of the baseball. All they have to do is code it.
So what's the future of all this stuff? Because obviously you're talking about unlimited orientations of a baseball. So a baseball can fly in literally almost, I mean, in infinite, because it could be a fraction off. Is there going to be a computer where I plug in various axes and orientations, and it's going to spit out how much that pitch is going to move?
We hope to build that computer. We're working on a model to do that. We have a model right now that works, I think, 75% of the time. It has a pretty crude model in it, but it basically, it asks itself, okay, if the ball's like this, or if it's like this, or if it's like this, is there a seam in this magic location? And if there is, I'm going to push down on it a little bit. And it puts that all together and comes up with the flight path of the ball. Once we have that thing correctly modeled, then we are going to just turn it loose. And I call it the seam shifted map of the world. We're going to say, show me everything that's out there. And at that point, we will know all the possibilities. And then it's just a matter of figuring out how to make a ball spin like that.
That's so you're looking for investors in this, or anything?
I am looking for investors in that, as a matter of fact.
Awesome. I mean, because this to me is, as I mentioned, this started me down the path. This is why we started talking, because I realized that what we have today, it's mind blowing, the measurement technology we have today, but it's also a little bit of pseudoscience. We're just measuring stuff, and then we're claiming that we knew the science behind it as coaches, because as coaches, we are not physicists, we're not scientists. We just read what we got, and we know enough to be dangerous. But the future of this,
you see a lot of data. Coaches and pitchers, they see a lot of pitches, and so they know things, and they have an intuitive feel for things that someone like me doesn't have. So it's definitely important, super important.
Right, but now combining it with that knowledge. So to me, that has to be the next level of baseball. That is where baseball goes. If I'm a pitching guy and I know that I feel like we're almost still in the stone, we just got out of the Stone Age. Stone Ages was velo doesn't matter, and we don't even have radar guns. We're just going, some guy gets somebody out, some guy doesn't, he's better than that guy. We can't even train velo. Now we realize we can measure velo, we can train velo, we can measure we can measure spin rate, we can measure spin axis, we can measure spin efficiency. We don't know exactly what that does, what orientations though actually matter when it comes to movement yet fully,
right?
And how much that's going to matter.
We still don't have a way to measure orientation. So even though now we have a way to see that the ball, how the ball moved, and we can see that it doesn't match what Magnus says it should, but we still don't have nobody in the world right now tells us what the orientation of baseball was. So we can't even do that. We can't even do that inference right now. I think that'll get solved really soon. But Hawkeye, Rapsodo do not tell you what the orientation of the ball is. So say that you get a feel for, hey, I'm getting 10 inches of seam shifted wake movement. You don't really know how much of that has to do with the way you were holding the ball yet.
So you need to marry that with something like an Edgertronic too, then, and have a high-speed camera behind.
That's how I do it. I do it by eye. I watch the Edgertronic video, and then I mess around with Trip Summers' pitch spin visualizer until it looks that way. I'm doing it by matching it. It's really crude and it's really painstaking, and somebody just needs to make something that will spit that out, which isn't hard to do, I don't think. It's over my head.
Some enterprising maybe it'll be us. Let's figure this out. But the other thing I'm noticing, and this is just an observation through this conversation, is that it almost has taken a village to move the game forward. You mentioned Tripp, you mentioned Michael Augustine, you mentioned we've mentioned Kyle and Trevor and just a bunch of folks that have gone at this problem and maybe moved the game forward in different ways to help solve it. Rapsodo, Yacker Tech, TrackMan, everything is part of this solution.
Jared Hughes.
Jared Hughes, exactly.
He sent me so much. So he was sending me video all through April, and we were doing exactly that. We're figuring out the orientation of the ball iteratively, visually, and then the Rapsodo would tell him what his efficiency was, and we try to marry all that up. So yeah, no, it's been a big group, but without people like him and all the people you mentioned coming and saying, hey, you know, what do you think of this, or can I contribute somehow? Yeah, I don't think we'd be here.
Yeah, and I think that's what's cool about the baseball community, is when you got a bunch of people that don't feel like, I don't feel comfortable I know all the answers. I know I don't know all the answers. I know that we all make mistakes and we're all willing to be open-minded, but we're all in it together to help solve the problems. I think that's the most important part of it.
I've been blown away by what you just, I totally agree with what you just said. I got to meet a bunch of baseball people back in March. I went to spring training and met with some Blue Jays and some folks from the Yankees and the Tampa Bay. And to a person, they all had that attitude. You know, they're coming from all different walks of life these days, right? It's not, you meet people in front offices that come from all different kinds of backgrounds, and none of them act like, yeah, I know everything. They're all people that are good at synthesizing a bunch of information and figuring things out and trying to figure out ways to meet the right people to help them learn. It's
so what? Yeah, I mean, I love this. That's what I love about the game. That's what I love about like what I do too, is I try to, I mean, I just think it's important to make the game interesting, to try to move it forward, because otherwise, what are we doing? I mean, I just, it's not fun to be stagnant.
Yeah, and I am totally hooked. You know, I became a bit obsessed with baseball just probably 10 years ago. I started watching a lot, but compared to now, I mean, it's an absolute obsession for me. That, and I can't imagine any other game being this rich.
Yeah, and we're like, exactly right. And we're just like, I feel almost like I want to fast forward to see where we end up, because it seems like there's so much we don't know, and we're finding our way through the woods. And again, I think it's bringing the real science into this, as opposed to all of us just guessing at it. Because I think we've also through meaning right, like we've tried to do the right thing, but we also may have messed up pitchers because we thought that we knew what we were doing when we said, you know, change your grip, and the grip was getting people out.
Yeah, and I know it's true. I do it with my kid. You know, I tell him do this, and then 6 months later, I'm like, don't do that. Do this instead. Well, you told me to, and I asked him, do you want me to stop talking? Do you?
Does he yell at you like my kid did?
He does. Yeah, he gets really upset when because that was about a year ago. I told him, don't bother with 2-seam and 4-seam. It's the same thing. And now I'm telling him, no, absolutely, you should alternate those. You should mix those in, because they're, you know. And he's like, Dad, you know, just 9 months ago, you were telling me exactly the opposite of that. I'm like, well, get used to that, because.
Yeah, I definitely went through there. If my kid's watching, he will absolutely know. But it's tough when your dad is just that smart, is what I find. It's tough to be a kid. That delusion.
He has. Yeah, I don't think he.
Yeah, that's definitely not true in my case either. So, future of the game, what do you think? Have you figured out what seam orientations yet will move the most? Do you know? Do you have a good idea?
No, I doubt that it would be amazing if what's happening now was the best thing that you could do, because it all happened by accident. So I would be very surprised if we don't find something that works much better. I think it's going to take about another year or two if we keep working at it.
And as you mentioned, you may find a pitch that actually can deliberately move in 2 different directions. We don't know. It may happen.
Yeah, I think the main prediction I would make, and I made this in my seam shifted weight predictions for 2020. The main prediction I would make is that the dominance of guys that throw high heat with a lot of spin is going to be dinged up a little bit by people that don't have perfect efficiency and that are getting this big movement from seam shifted weight. I'm hoping that we'll see a little bit of a shift towards a different kind of pitcher, and that we can broaden the number of people that are able to be competitive. All these people that are on the scrap heap right now will have a shot.
So my prediction last year, if you might remember, is that science would actually start taking over baseball as opposed to the measurement technologies, which I still believe is going to happen thanks to this people like you. I think bringing in real scientists into teams is going to be important. I don't know if a team wants to own this or doesn't want to own this. Maybe they become it. It is an advantage. It is an advantage. It's a Moneyball type thing. You can take somebody who's undervalued and help his arsenal, right?
Yeah, I think there's a huge player development potential in it right now, and I think somebody could own it, and I'm surprised that nobody has tried to do that. But yeah,
you've talked to some teams.
Yeah, I've talked to some teams, and happening in the middle of a pandemic was both the best and worst thing that's happened. That's been an interesting aspect of the story too, because pandemic is what allowed me to work with Jared the way I did. He didn't have a contract at the time. He was stuck at home. And so we were able to do a lot of really important things that wouldn't have happened outside the pandemic. And then at the same time, all the baseball teams are suffering financially, or so they claim. And so you're not seeing a lot of people running around looking for a big investment. But what's surprising to me from the point of view of the teams is that wins have a dollar value on them. And I absolutely believe that there are wins in this idea. And the dollar value attached to it is really small compared to what it would be to try to, say, acquire a player that would give you a win.
Right. Or taking a player that you currently have and turning him into a Dallas Keuchel or Kyle Hendricks. I mean, that seems like a good investment.
Yeah.
And what would it cost to get you? I mean, would it be? I mean, it would be like a fraction of $20 million.
Yes, it's a fraction. It is a fraction of $20 million.
So there you go. I mean,
$20 million.
But so yeah, I think this is so exciting to me. It's great to talk to you about this possibility, and I am excited to see what happens in the next year or so as you and I invest in developing this unlimited seam technology that determines which ball is going to move the most.
Yeah.
Do you have anything that we haven't touched on?
I can't think of anything. That was a lot of fun. I don't know if you want to put a clip of me kissing your butt in there, but it's quite a pleasure to meet the pitching ninja. I seriously, thank you for what you do. And I think it's done so much to interest people in the game. And I think that's what your aim was. And to point out that pitchers are interesting players and interesting people. So thanks for that. And it's done a lot to inspire my interest in it and get us where we are.
Well, that's awesome to hear. And I will say that the one thing that has interested me the most in this type of thing is pitching is the most interesting part of the game to me, because you're in control of this baseball. You can do all these unlimited axes and make the ball move in different ways that we haven't figured out yet. We haven't discovered yet. So pitching is the new frontier, and we are always going to stay ahead of hitters because of that. A hitter can't control what he does, right? I mean, you can't control what spin you put on the ball. The ball's coming at you fast.
Big difference between me and you, and I would never say we, because I don't count myself as a pitcher. And that's one of the things I struggle with when I talk to people. They always want to talk to me about grips, and I try to explain to them, I think of the ball after it leaves your hand. That's the only, that's where my job starts. So how to get it to spin like that, you need somebody more athletic than me.
Yeah, that makes it. Devin Williams is airbender. He said it's not the grip at all. It's how it leaves his hand. Yeah. Similarly, every single ball orientation, a grip is just a way to get that orientation, right. And everybody's fingers are a little bit different too.
Yeah, something that's just hit me, and I'm sorry to take more of your time, but
no, absolutely.
I started teaching my son a changeup, and what I noticed, and I'm sure that everybody knows, is the changeup has an axis that's different because you change the way you release it. It's not the grip; it's the fact that you pronate and roll your hand over it. And I've heard that Hader gets the weird axis on his fastball because his wrist is at a different angle when he lets go. So there's these other variables that people don't talk about that much or don't acknowledge that I'm just learning about. And that's a whole nother dimension to it. So now you have your arm slot, you have your grip, you have your release, and now we have the orientation too. So
yeah, well, and that's again the part where, as a coach, you may coach somebody out of this weird release that they have, and you're trying to teach them different releases that may not work for them. So everybody's different. Everybody does things differently. Hader didn't decide to do it. It probably is the way he throws.
Mm-hmm.
And he could have been coached out of it.
Yep. And again, just to talk about how much we love baseball. I mean, that's the beauty of it. I didn't realize before I got this deep into it, how individualistic it is, how each individual finds their own way, given their own anatomy, to make the ball do what they want it to do. And it's amazing. And it makes the coach's job so challenging to look at an individual and say, how can we use this person? So just recently I realized when I had a minor leaguer come to me and say, what can I do with seam shifted wake? And I look at him, he throws straight over the top, he spins the heck out of the ball, and it's really efficient. And I'm just like, I don't know what I'm going to do with this guy. I don't think that he's the right guy for me, unfortunately. Yeah.
Well, so we've now made a coach's job easier and harder. It's harder to me. Like, I used to think we knew the answers to, hey, you do more spin. Now we're talking an infinite amount of mechanics times an infinite amount of orientations.
Yeah, if you're a baseball organization and you have this pile of pitchers and you said, well, I don't want these because they don't spin the ball well enough or they don't throw the ball hard enough. Now I'm saying you better go look at these guys again.
I mean, this could save some franchises and save some careers. So if you're a pitcher out there who maybe doesn't throw hard enough, maybe doesn't spin the ball well enough, you can solve it through orientation potentially. How do people contact you? I know it's at not real certain is one way.
Yeah, barton.smith@usu.edu is another. That's my email address. But I have baseballaero.com. You can contact me through that. And I love talking to people. I love it when people send me video of their pitch and ask me what I think. I love to tell you what I think. So that'd be great. It sounds like you're wrapping up, but I want to go back to the comment about not spinning the ball well. How fast does Kyle Hendricks spin his fastball?
Off the top of my head, I don't want to be wrong. It's
below 2,000 RPM.
Yeah, that's what I would have guessed.
Yeah. So
I know his curveball spin rate is pretty high too. He's had a couple of 3,000s, but I didn't realize. So that actually is a great point. We're all into bigger numbers or lower numbers. To me, it's how do you give somebody a different look, something that they don't see, so that's how you're effective. And the way we've all determined that is it's either off the charts fastball velocity, spin rates that are off the charts high, with high efficiency, or really low, so it's a sinker that just dives out of the zone, or various orientations of spin efficiency regarding sliders and curveballs. You obviously want a 12-6 spin ideally. Now we're talking about a whole different measurement thing that coaches and talent evaluators, they may not have. This pitcher may be getting people out. They may be doing really, really well. You may see it with your eyes at the pitch moves, but your readings, everything you have to evaluate that pitcher, is not telling you that this guy is somebody you want.
Right, and it is very analogous to Moneyball, because basically it's a market inefficiency. You're looking at the wrong numbers.
So for college coaches too, this is something they may want to be interested in. As this science gets further, there may be people they're recruiting that are really special in the way they throw pitches that don't show up on anything the way they've traditionally measured pitchers.
Right. I believe that.
Yeah, fascinating. This has been awesome.
Well, I've been waiting for it for forever, so it definitely was worth it.
Strike three, y'all!